Geometry lesson 4.4. We're going to start to prove triangles congruent. Here we go. Side, 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 SSS. Our first triangle congruence postulate is side, side, side. If you can show that three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent by side, side, side. Okay? Adjacent triangles share a side, so you can apply the reflexive property to get a pair of congruent parts. So use SSS to explain why ABC and DBC are congruent. Well, you can see those are marked. Those two are the same. And BC is equal to itself because of reflexive. So that gives you side, side, side. You show that three sides are congruent. Use side, side, side to explain why these are congruent. Well, marked and marked. These two are marked. And then once again, AC is equal to itself by reflexive. So they are congruent by side, side, side. All right. An included angle is an angle formed by two adjacent sides of a polygon. B is the included angle between sides AB and BC. C is the included angle between sides AC and BC. Okay? It can be shown that only two pairs of congruent sides are needed to prove the congruence of two triangles if the included angles are also congruent. This leads us to our next one, side, angle, side. If two sides in the included angle of one triangle are congruent to two sides in the included angle of another, then the triangles are congruent. So you see how this angle is included, is in between the two sides on both triangles. Has to be included to use side, angle, side. All right. The letters side, angle, side are in that order because the angles must be between the pairs of congruent corresponding sides. This diagram shows part of a support structure. Show why they are congruent by side, angle, side. Well, the two sides are marked, and then we've got that angle and that angle. Those are vertical angles. Vertical angles are equal, so side, angle, side works for those two triangles to show they're congruent. Use side, angle, side to explain why these two triangles are congruent. Well, we've got our side, those two angles are marked, and then they share a side BC by reflexive, so that works by side, angle, side. Okay, the SAS postulate guarantees that are given the lengths of two sides in the measure the included, you can construct one and only one triangle. Show that the triangles are congruent for the given variables. So x is 5. So that's 5. That's 7. That is 6. 5, 7, 6. 5, 7, 6. How do we know those are congruent? Side, side, side. Y is 4. So 7, 11, and 4 times 2 is 20, 92. 92, 7, and 11. It's in between. It's included. So side, angle, side works for those two triangles. Okay, so here's where we're going to do the bulk of our proofs this year with proving two triangles congruent. Remember, Mr. Walmuth will give you how many steps. So this is a 4-step proof. So we always start with our givens first. So BC is parallel to AD, and BC is congruent to AD. That's given. And then we're trying to prove triangle ABD is congruent to triangle CDB. So we've got the proof skeleton. So we know we've got 4 steps. So let's look here. Well, take the easy one first. We're trying to prove those two triangles congruent. They share BD. So you could say BD is congruent to itself by reflexive. Okay, so we've got two sides. Now we either need to show another side or another angle. Well, since these two lines are parallel, what kind of angle pair are those two angles? They're alternate interior. So since they're parallel, we can say that those two angles are the same. angle CBD is congruent to angle ADB by alternate interior angles. So we've got it. Side, angle, side, side, angle, side. The two triangles are congruent by side, angle, side. Now that's kind of sloppy. I apologize, but pen doesn't write that great. But side, angle, side. All right, let's try that again. Maybe I'll make my pen a little bit smaller. Okay, QP bisects angle RQS, and QR is equal to QS. Those are our given statements. So we would put the givens there. That's our step one, 4 steps again. So we know that's given. Now we're trying to prove triangle RQP is congruent to triangle SQP, and that's what we're trying to prove. Okay, so we're trying to prove these two triangles congruent. Take that easy one when they give it to you. QP equals itself by reflexive. Okay. Now, QP bisects RQS, the angle. So that means that those two angles are the same. So angle RQP is congruent to angle SQP. And how do we know that? We know that because of bisector. You could just say definition of bisector. Put something about bisector. Cuts it in half, makes them the same. And there we go. Side, angle, side, side, angle, side, angles included. So our two triangles are congruent by side, angle, side. Okay, so 2 4-step proofs.